We're continuing our study of statistics by now looking at distributions that have two variables. So far, we've only studied distributions with one variable. For example, we often talked about having a list of scores on a test. That's just the one variable. If we were to be studying two variables, it might be the scores on a test and the age of the student. See if there's a relationship between those two things. So that would have two things that are changing, the age and the grade on a test. So for example, here, the example that's given is if we're comparing the age and height of a group of grade 1 students. So we're expressing the data for each student as an ordered pair. So the first number is the age, since it was mentioned first in the problem. And the second number would be the height, since it was mentioned second. So if we were to graph this, which we will be doing eventually, the first number would be the x, and the second number would be the y. So now we're going to study correlation. We're going to study to see if there is a relationship or a correlation between these two variables that we're studying. So when we're trying to find a correlation, we're trying to see if there's, like I said, a relation between the two values in our set of data. So we can describe the relationship in a number of ways. We can describe the type, the direction, and the intensity. We're going to be focusing mostly on the direction and the intensity. We can say that the correlation between two variables is positive when the value of one of the variables increases and the value of the other variable also increases. It also works in the other way. If one decreases, then the other is decreasing also. But the point is that they are changing in the same direction. Let's write that down. Change in same direction. So if one is increasing, the other is increasing. That makes it positive. Negative, well, if one is increasing, then the other is decreasing. Or vice versa. If one decreases, then the other is increasing. The point being that they change in different directions or opposite directions. And finally, a correlation can be zero correlation, so no correlation at all. It can be very weak. It can be moderate, so of course sort of in the middle. It can be strong, or it can be very perfect. And we'll be looking at different ways of figuring out what the intensity is of the correlation. A contingency table is one way that we can represent our two-variable distribution. And it can help us determine many things about the distribution, but most importantly is it can help us determine the type and the direction, so whether it's positive or if it's negative. Here we have a few things to note about a contingency table. This outlines a few things that are important about a contingency table, and I'll illustrate each point as I work out an example. So we have an example here, example 1. Here we have each ordered pair represents the age and the number of branches for 20 different trees. So each one of these ordered pairs is for one tree. This is the age of the tree. This would be 12 years old, and it has 160 branches. So we're going to first identify our variables. We're going to say X represents age, and Y represents number of branches. And now we're going to organize all this data in our contingency table. So if we go back to the points written up here, the first point is that one of the variables is associated with the first column, and one of the variables is associated with the first row. So we're going to identify which variable is identified with the first row and then with the first column. So we do that by, we're going to split this first cell. And so we're going to say that the first column is the number of branches, and the first row is the age. And then the next point is that we can arrange the data into classes. We can group the data into classes. So I'm going to group the data for branches into the following classes. So I'm going to look at what data we have for branches, what numbers we have. And if you examine it, you can see that the smallest value for branch is somewhere 100, somewhere between 100 and 200. So the first class is going to be 100 to 200. And we're going to continue up to 600. So 200 to 300, etc. I'll finish that in a moment. And then if we look at age, well, we can see that age is ranging, the smallest value is somewhere between 10 and 15, it's probably 12. And then the next one will be 15 to 20. Okay, so you can finish filling in the first column and the first row. Pause the video here and do that, please. Okay, so I finished filling in my first row and my first column with my groups, with my classes for my data. So now I'm going to look at the next point. The next point is that the row and the columns indicate the total frequencies for each value that fits into that class. So what does that mean? Well, that means we're going to look at each number and we're going to figure out which box it's going to fit in. So my first value is 12 and 160. So 12 is going to fit in here and 160 fits in here. So that means in this box we have one piece of data that falls there. So I put a little tick mark. Then I look at the next one, 13 and 145. 13 is here, 145 is here, so I put a little tick mark there also. Next one, 13 and 220. 13, 220 is here, so we fall into this box. So I'm going to do that for each number, and each ordered pair, and once I've finished it, I'm going to cross it out to make sure I don't repeat it. So I'd like you to try and finish filling out our box with little tick marks for every number. Pause the video here, please, and do that. Once I've finished my tally, like I have here, I can then write into each box what the total frequency is. So in the first box here, I can see that I only have 2 tally marks. That means there's only 2 data points, 2 numbers, or 2 set of ordered pairs that fall into this box. So I write 2. In this box, we only had 1 that fell into here. Here we had 3, 4, 1, 2, 5, and 2. Everywhere else, where there's no tally marks, it means 0. There is no set of ordered pairs that fell into these categories. No trees that met these criteria. And then once that's finished, we're going to find our totals. So we read across this way and write the total for that row. So this one is 2. Here it's 4, 5, 7, 2. Then you find the total for each column. Read down this way, find our totals. So here we have 3, 3, 6, 6, 2. And the total both ways, the total this way and the total this way, should give you the same thing. It should give you 20, which is our total number of data points. When we're told at the beginning here, we're looking at information for 20 trees, so our total here should be 20. Now that we've filled in our contingency table, we can answer some questions about our data. So the first question is, what is the correlation between the number of branches and the age of the tree? Now we can find the correlation, and this is actually the last point that was given earlier, here this point. The correlation is linear when the majority of the occurrences or the frequencies follow one of the diagonals. So if I look at my contingency table, I look at the diagonal. Here's one diagonal. Here's the other diagonal. Well, this diagonal, we can see there's not many numbers in it. But this diagonal, we can see almost all our numbers are grouped around this diagonal. So that means there's a linear correlation. I'll write that down. It's linear. Whoops. But what we really want to know is it positive or is it negative? So the diagonal is going in this direction. So we're moving this way and we're moving this way. So as we go across, well, the ages are increasing. The ages are increasing. And as we go this way, the branches are increasing. So they're both increasing. So they're changing in the same direction. So that means that it's a positive correlation. Now we can find out other things as well. Like question 2. What percentage of trees contain 300 to 400 branches are less than 25 years old? So we look at 300 to 400 branches. Well, we have 5 trees. So that's our total number of trees that are from 300 to 400. That's my total. How many of those trees are less than 25 years old? Well, here they're less, and all here is less than 25. So that means there's 4 out of 5 times 100 to give us a percentage. So that gives us 80% of our trees. Now I'd like you to try and answer questions 3 and 4 on your own and bring that to class and we can discuss it next class. And I'd like you to try on this page, the second example. You're given some information here. You're given some data about the age and height of a group of students. So the age is the X, the Y is the height. I'd like you to create a contingency table like we just did, and then answer the question about the correlation. Is it a positive or negative correlation? Pause the video here, please, and complete the contingency table. Another way to display a correlation of 2 variables is using a scatter plot. So basically what a scatter plot is we take our points. So when we have 2 variables like we saw last time, we always have an X and a Y, and we're going to graph those. One variable is always associated with the X, another variable is associated with the Y. So you're going to graph them, and for each point, you put a dot. So you're going to get a bunch of points. And then we look at how the points are lining up, and it can tell us the type of correlation that we get. So the information is given here. The correlation is said to be linear when the points tend to form a straight line. And the correlation is said to be 0 if there doesn't seem to be any arrangement. And if we look here, you're given examples of each type of correlation we can get. This is taken from your textbook. Let's go to the bottom. We'll start here. This is a perfect positive correlation. See, all of the ones in this column here are positive correlations. All of these are negative. So if we go back to the bottom, we look at the perfect positive correlation. So we can see that they're lining up in a perfect straight line, and as the first variable increases, this one's increasing also. Here, they don't line up very well, but they're still very closely clustered together. We almost could draw a line here. So it's a strong positive correlation. Same thing in the negative. If we look over here, they line up perfectly, but it's slanting the other way. It's perfect negative correlation. Here it's a perfect strong correlation. The next one is moderate. Same thing, we could kind of draw a line, but the points are really scattered. And then here it's very weak. The points are even more scattered, even more all over the place. And then the last one is a 0 correlation. This one here, they're not slanting in any one way in particular. They're all over the place. There's no correlation. The first variable and the second variable aren't related at all. So that's how to interpret a scatter plot. Tomorrow in class, we will also be drawing scatter plots. So make sure you have some graph paper tomorrow for class.